Hello everyone and welcome back to session 4 of Warwick Data Science Society's course, Beginner's Python. So by now you should know the drill. We're going to start with a quick recap of the stuff we looked at in last session, adding a few additional points, and then we'll move on to some new content today. So if you're watching one of the hybrid live sessions, now is your chance to pop any questions from last time or from the homework in the chat. We can have a look at those before we get started. So looking back at a quick recap of last time, we looked at two main things, so control flow and loops. Control flow was used to add some logic to our code to allow branching, running different bits of code depending on whether certain conditions were met. And then loops were kind of, fairly similar in that they allowed us to, rather than branching code, to rerun bits of code until a condition stopped being true. And so we had a look at those, and it wasn't explicitly mentioned whether or not we were allowed to put these inside of each other. It turns out, Python being a flexible language, that you can do that. You can put ifs and elses inside of other ifs and elses. You can put whiles in other whiles. You can cross them over. Nothing wrong with that. So I have two examples here just to really illustrate this point. So here we have a script that will take a number and print one of three responses. So it's a multiple of 6. It's even but not divisible by 3, or an odd number. And so to do this, we have two levels of ifs here. And the word we use for putting one if statement in another, or actually for putting any sort of control flow in another, is called nesting. And so the first check we do, we ask, is n, so this percentage symbol here, I think we might have seen it in the homework, so if you haven't come across it, it means the remainder when we divide by that number. So is the remainder when we divide n by 2 equal to 0? In other words, is n even? If it is, then we immediately start another if statement, asking, is n a multiple of 3? If it's a multiple of 2 and 3, then it's a multiple of 6. So we can print that out. Otherwise, it's not a multiple of 3, but we are in this indented bit here, and so we must be even, but not a multiple of 3. Therefore, we print this out here. And failing the first condition, if it's not even, then it must be an odd number. As you can see here, we're completely free to nest things as long as we just keep indenting one new level of indent for every nested either control flow or loop. And in a similar way, we can have two while loops, kind of one inside of the other. And I'm not going to go through this example, but all it does is print out a pyramid of numbers. You can break this down for yourself if you want to kind of figure out what's going on there. Okay, so looking towards the rest of today's session, we're going to be talking a lot about lists. So this is kind of the time that we bring together kind of what we introduced in session 2, kind of introducing these numeric lists and the basic operations of sums, mins, max, and the length of a list, and kind of really bring that together to properly understand what a list is and how we can manipulate it completely. And then we'll close up by talking about these things called tuples, which are very similar to lists, but have some subtle differences that are important. So with that, in the hybrid live sessions, we'll pause to take any questions. Otherwise, we'll join back in a second to get started on today's session. Okay, let's get started with today's session. So the first item on the agenda is non-numeric lists. So we saw in session 2 how to create a list of numeric values, and that was using square brackets with numbers separated by commas. And so Python, being a flexible language, is very capable of making lists of any data type. So you can have lists of text data, which would be a string list, lists of logical values, so a Boolean list. You can even mix different types together into kind of a mixed list. Although, as we'll see later, a tuple is actually a better type for having a mixture of values, but you can have a list of multiple types if you want to. And so, yeah, the way of defining these is the same as with a numeric list, square brackets, and then entries separated by commas. So for example, a numeric list, as we saw before, numbers separated by commas. Then we could have a list of strings, so kind of a list of text data, with each string in its own quotes, separated by commas, or a Boolean list containing true, false, and true. And finally, we mix these all together. Nothing wrong with that, but the tuple is a better type for doing that. And so Lists are a very simple way of storing multiple bits of data by a single name. I mean, you can imagine here if 5, 8.4, and I guess let's say this is positive 2, were the heights of various people in some obscure unit. We would not want to have 3 variables for keeping track of each of these, height 1, height 2, and height 3. Or maybe, going up to height 100 if we have 100 of them. It's a very complicated way and inefficient of storing that data. Instead, a list is useful when we want to have a single name for talking about a whole collection of data. But the most important part, or the most important characteristic about a list, is that it stores its elements in a specific order. Like we can clearly see here, there is a first, second, and third element here. And it would carry on with those going forwards. And so lists are therefore only useful for when we're trying to store data that has kind of a natural order to it, or when we just don't care about the order at all. Because if there is a natural order, we'll put them in that order. If we don't care about the order, we'll put them in any old order. For example, if we had different competitors in a running race and we knew who came first, second, third, etc., we could put them in a list where the first place, so the winner, was in the first position in the list, the first item. The second place person was the second name in the list. We carried on like that. In that case, there's a natural ordering. Or we might have a case where we just want to know who was in the race. We don't care about the order. We then just put them in the list in literally any order. Wouldn't be a problem. But we would come into difficulty if we cared about the order, or we cared which one was which, but there was no natural ordering. So for example, what if we were trying to store the populations of various cities? So we wanted to know, Beijing has this population, Stockholm has this population, etc. There's no natural order to put those in. Do we put Beijing first? Do we put Stockholm first? Maybe Paris. There's no natural way of storing them, and yet we need to be able to retrieve a certain population given a city name. And so it becomes like a really complicated problem that a list is just not meant to solve. And we'll see in a later session, there's this thing called a dictionary that allows us to solve this. But for now, lists are going to be used for things that have no order or have a natural ordering to them already. So with that, we're going to have a go at a puzzle here. So we'll just pause for a moment, have a go at that, and we'll join back again in a moment. Okay, let's have a look at these solutions then. Actually, before we get to that, let's just kind of go over why a list is an appropriate data type for this first question here. So we're creating a list of the Star Wars films in the order of their release. So that's the hint there. If we're writing them down in the order of their release, then a list is an appropriate type because we have a natural ordering. In a similar way, if we were just asked to list out the Star Wars films in any order, a list would also be appropriate because they also work when we don't care about the order. So no problems there. Anyway, the solution will look something like this. So we create a variable called Star Wars, and we're assigning that this list here. And you'll see, I put this across multiple lines here. It means the exact same thing. I could have put one really long line here, but it would have been quite hard to read. In almost all cases, Python does not care about new lines, about spaces, about tabs. It's only special cases like when we're doing an if statement that sort of thing matters. So we're free to put these on new lines just to keep things easier for a human to read, but Python doesn't care. And so here is an interesting one. We were asked to create a list of lists. So putting lists inside of lists. And yeah, we're free to do this. We could actually put, any number of lists inside of more lists going, an infinite length down. And so here we have the outer set of brackets. And here, having multiple different lines for our list really helps clarify what we're doing. So the outer set of brackets here, and then we have 2 elements inside separated by a comma. And so, as we mentioned earlier, lists can contain, they can actually contain any object. And so there's nothing wrong with having another list as one of their elements. So here we have a list inside, which own square brackets and a comma to separate 2 values, 1 and 2. Then we have a second list here with the values 3 and 4. And so this is a very interesting example because, this looks a lot like a data set. You can imagine each of these interior lists being a column of our data set, or could be a row as well. And then all of these being all the columns together grouped into a data set. So It was still quite a way off being able to properly do data analysis and work with data frames, but you can start to see the ideas coming together that this is how we could store more complicated data, such as a whole data set. Okay, so we know how to create a list now. The next thing we're going to want to do is to actually manipulate and work with lists. So the first thing we're going to do is to extract elements out of a list. So we put them in, let's take them back out. And so lists are composed of multiple elements. These will sometimes be called items as well. And so each element has this thing called an index. You can think of this as its address. In the same way that, if you wanted to know where someone lived, you need their house number. If you want to know where some data lives inside of a list, you'll need its index, its address. But the difference between real house numbers and these indices for lists is that the indices in Python start at 0. So it's the same as normal house numbering systems. We start from 0. The first house, the first element, has number 0. And then from there, we simply increase going upwards. So the second one will have index 1, the third one index 2. And so we can then access an element from a list by using square brackets and the index, so the address of the element that we want. So for example, we have a list here called shopping list. It contains 4 strings separated by commas. And let's say we want to extract the third item. Okay, so that's bread here. That's the third one. Well, this first one, as we mentioned, we start at 0. So this has index of 0. It's in the address house number 0. The next one is going to have 1 and then 2. So we want the second index. That gives us this third item here, bread. And so we can simply take our list, follow it by square brackets, and then put in the number or the index we want to extract. Here we put in a 2, and we get the third item, the second index, bread, as the output here. So it's actually a bit more nuanced than that. Every item or element in a list actually has 2 addresses, a positive one and a negative one. And so this is a feature of Python that isn't present in some languages. And though it might seem a bit confusing at first, it's really, really convenient in a lot of use cases. And so whereas the positive indices count upwards, starting from the beginning of the list, the negative ones start from -1 at the end of the list and then count downwards. And so this gives you a way of accessing things from the start of a list and from the end. And depending on what we're trying to extract, one of those might be more convenient. And so the last one's going to have it's going to have index -1. And then the second to last one will have index -2. And it keeps decreasing down. And so let's have an example of using that. For example, we have a list of people's names and where they came in a race. And we have that the first place person was the one at the end here. So Dan finished last and Bill finished first. And we want to know who came in second place. Well, so we could kind of count all the way up. So we go Anne's in second place, 0, 1, 2, 3. But to be able to do this, we have to know how long the list is. You can imagine that if we added a new person at the start here, someone just finished, then Anne's now going to have an index of 4. So it's really hard to keep track of. We have to know how long the list is in advance. But if we use negative indices, we can start from the end and count backwards. So Bill also has index of -1. And then go one further back, -2. And if we wanted cat, it would be -3. But we want the second person in the race, which is Anne, -2. And so we use that here, and that's going to give us Anne. So, this is now robust too. We could add more things at the start, but because we're kind of relative to the end of the list here, we don't have to worry about that. So it's a very convenient way of indexing. Okay, so now we're going to have a look at some puzzles involving extracting elements from lists, and then we'll join back again in a moment to look at these solutions to those. Okay, let's have a look at the solution then. So we were asked to create a list of 5 colours and extract the middle element in 2 ways, positive and negative indexing. So the list I went with was the colours of the Olympic rings, and so the middle element here is the colour black. So for positive indexing, we start from the start. Remember, the first one has index 0, so 0, 1, 2 gives us this black here. And for negative indexing, start at the end with -1, -1, -2, -3. And so both of these will give us the colour black here. And so the general rule is that if we want the nth element, so say the third one here, we take 1 off that number 3 to get 2, and that's the index we want to use. And that makes up for that, that offset from starting from 0. If you want to know the general rule for the negative one, it's a bit more complicated. It depends on the length of the list. So we'll leave that for now. Okay, so that was how we could extract a single element from a list. How could we take a list and kind of extract a subset of it? So extract a sublist from inside of it. And so, for example, we might have a long list and only want the second to the fourth items. Just take those out as its own list. How could we do that? Well, the answer is using a thing called a slice instead of an index. So whereas an index is a single number, a slice takes 2 indices separated by a colon and will give us a list going from the first up to the second. But the important thing about how a slice works is that Python will return everything from the first index up to, but not including the second index. So I think that's better seen in an example. Here we have the past and present Prime Ministers of the UK, so Johnson back to John Major, and we want the 3 most recent ex-Prime Ministers. So skipping Johnson and then having May up to Brown. And so we can do this using a slice. So we're going to want to go from, so we have Johnson 0, May is 1, 2, 3, 4. So we're going to go from May, which is 1, and we want to go up to Brown, who has index of 3. But the important thing is the last, or the second number in a slice, that index is not included in the final thing. So if we want to go up to Brown, we have to go 1 further up to Blair. So we're going to go from 1, 2, 3 up to 4. So 1 colon 4, that's going to give us elements 1, 2, 3, but not 4, which is May up to Brown as we intended. Okay, so yeah, let's have a go with applying that in this puzzle. We'll join back in a second. Okay, so hopefully there wasn't too much trouble with that. Let's have a look at the solution now. So we're going to have something like this. We have the names of the 7 dwarves here. You could have had them in any order, but I ended up with this one. And so we want to extract, was it the middle 3? Yeah, the middle 3. So grumpy, happy, and sneezy. And so we're going to do this with positive indices first. We can just do this by counting up. So 0, 1, so 2, we want to go from 2, up to 3, 4, and then go 1 extra because we won't include the last one, so up to 5. So there we have 2 to 5. That's going to give us those 3 elements here. And we can also use negative indices. The important thing to bear in mind, as the note said here, is that slices go from left to right. So we have to start with the most negative one, which is going to be more to the left. So we have -1, -2, -3, -4, -5. So from -5 up to -4, -3, and then go 1 further to -2 because we don't include the last one. So that will achieve the exact same thing here. And so yeah, the key thing to remember, the first one is included, the second one is not included. And so the reason for this, kind of the logic behind it might seem quite arbitrary, is that the difference between these numbers, between 2 and 5, is the number of elements we get in our slice. So the difference between these, 5 minus 2, says we're going to have 3 elements in the final slice. If we had it that 2 to 4 meant extract these out, well, then the difference would be 2, yet we've extracted 3 things. And so, although it might seem confusing, it actually ends up becoming a lot more intuitive because you can instantly see how many elements you're taking by the difference in these 2 numbers. Okay, so let's have a bit more of an in-depth look in how we can manipulate and handle lists. So we're going to have a look at 4 different techniques we can use for adding to, overwriting values of, and deleting values in a list. So various different methods. We're going to practice these on a list I've created here called guests, which contains Anne, Bob, and Cat. So we'll start by adding a new item to the end of the list. And we can do that using the .append method. So we've seen functions before, And methods are very similar to functions. I'm not going to get into the details of exactly how they differ, but rather than kind of putting the function at the start and something in the brackets, we put the thing we're acting on, then a dot, then the method slash function, and then any options in the brackets. So if that sounds confusing, you can just follow this notation. But you can tell something's a method if we do something dot something. And the idea is kind of like a method is a function that belongs to a certain thing. So this append method belongs to the list guests. So we can take this guests and then use dot append to add an item to the end of the list. So here we add Dan to the end, we print out guests, and we get Anne, Bob, Cat, and Dan. Okay, and so we're going to now reset that list back to what it was before. How can we change an element in a list, so overwrite an element? Well, we can do that by kind of extracting the item and then setting it equal to or assigning it a new value. So here we have guest. We take the first index, which is the second item, so Bob, and then replace that with Barry. So we've replaced Bob as our guest with Barry. We print that out, we get Anne, Barry, and Cat. We can also delete an element by its position, so by its index. And to do that, we extract that value, so guests, and then whatever index we want. So here we have the number 1, which is again Bob. And we prefix that with the word del, the keyword del, which is short for delete. So delete the first index here. That's going to leave us with a list of 2 elements, missing Bob. And finally, we can also delete by value. So there we deleted using the index. We can also delete by whatever value is in the list by using the dot remove method. So similar with append, it's the name of the list, then dot remove, and then we pass in a string, which is the value that we want to remove. So here we put in Bob, and we remove that. So 2 points on that. Poor Bob, always getting uninvited. But more importantly, what happens with dot remove when either we can't find the value we're searching for, or there are multiple instances of it? So in the case where there's multiple instances, Python will delete the first one. So we have guests equal to Anne, Bob, Cat, and Bob, and we remove Bob. Only the first instance will go. We'll keep the one at the end, and any more if there were more. And if we can't find one, then we throw an error, and it just says a value error saying that we couldn't find, say Barry in this case. Barry wasn't in the list, and so we have an error. I think I show in the additional notes how you can handle something like this to check in the first place before trying to delete, to avoid getting an error. Okay, so let's have a go with these puzzles here. Then we'll join back to talk a bit more about tuples and how they differ from lists. Okay, so quite a few things to look at there, but we'll break it down bit by bit. So we start by defining the list of numbers at the top there, so something like this. Just separate them all by commas. We then add on the number 4 by using this dot append, and then we use this dot sort method to order things. This is going to take the list of numbers and sort them in ascending order. I think if you want to put things in descending order, you can use reverse equals true inside of this. But if you want to confirm that, just have a search for Python sort method. You'll find the documentation for that. So then we wanted to replace the smallest number with the number 2. And so because these are now sorted, the smallest number is going to be having index 0. So we can overwrite that with a value of 2 here. We then want to delete the 5th biggest, and again, because they're sorted, the 5th biggest will have index -5. So the biggest has -1, -2, and we count down. We could have used numbers 3 as well, but we'd have to know the length of the list to do that, so a bit unreliable. And finally, we calculate the average of these numbers, so we take their sum and then divide by the length of the numbers, how many there are, and that gives us the average or mean value. Okay, so we're going to wrap up today's session by talking about tuples. So tuples and lists are very similar, but there are a few key differences. So we define them in similar ways, but whereas lists we use these square brackets, with tuples we use parentheses or these kind of curved brackets like this. And so, for example, we can create a tuple with these 4 numbers called my tuple. We use curly brackets, or kind of curved brackets, sorry, with the values 3, 1, 4, and 1. So we can extract and take slices of tuples in the same way. So we can use square brackets. So this is the confusing thing. Even though we create tuples with these curved brackets, we index using square brackets because curved brackets at the end of a thing are reserved for functions. So if we use square brackets to index, that's going to return a number if we put in a single index here, or for a slice, it returns a tuple. So the main difference between a tuple and a list is that once you create a tuple, you can't manipulate its values. It's fixed. So we can't append, can't delete, and we can't overwrite. So here's a summary of the differences. So with a list, we can append to it, add new values, delete values, we can overwrite values, no problem. But a tuple, once it's been created, that's it. We can't manipulate it. And so we mentioned earlier that lists can contain multiple types, but it's better to have them having a single type. They're more efficient for that. Whereas a tuple is kind of under the hood set up so it's more efficient with different types. Now, a tuple sounds quite restrictive. Why would we want to create a thing that we can't manipulate at all? And the reason comes down to efficiency in memory and in speed. So the problem with a list is that its length and the values it contains can always be changing. And so Python is unable to reserve a block of memory to say, okay, that's the memory for the list, because if the list changes size, you might have to extend that memory or move it around. It's a bit more complicated to handle it. But with a tuple, where we know we're not going to add, delete, or change anything, we can give it some memory and just kind of slap a reservation on it. That's yours, and it's not going to need to be changed at all. So that's a lot more efficient. And so whenever we don't need to be changing the values in a data type, well, then a tuple is a more appropriate choice and is more efficient. Although I should mention the speed gains are small. It's only when you really care about those differences that it's worth bothering. So let's have a go with making some tuples and just confirming the fact that you can't manipulate them as you can with a list. We'll join back in a second to end the session. Okay, so let's have a quick look at these solutions. It's something like this. So we create a tuple with 3 values, a number, some text, and a Boolean value. We want to extract the Boolean one. I have this as the third position, so the second index. We use square brackets with the number 2, and that extracts it out. We can try to append, we can try to delete, we can try to overwrite, all those, it's not allowed. And so we get an error here saying that a tuple is not capable of being manipulated. And the error might be slightly different depending on what we tried to do, overwriting, appending, or deleting. So finally, just to confirm the types of these objects, we create a list as well, and we print out the type of the list. It is a list. Print the type of a tuple. That is a tuple. So no surprises there. So with that, thank you for coming to today's session, and I will see you next week.